Uh, okay, to begin with, so let me share you my screen here. Share my screen, share my desktop. Okay, so as we are into the 13th week right now, uh, so I am gonna go through chapter 6.4 and 6.5 today with two examples from each chapter, global arrays and the local. Oh, we get participant. Okay, admit. Okay, we got two more participants. Good. So if we get more, let's see. Okay, so I'm going to go through two examples from each session today. Then there are a couple of additional textbook example explained, but I don't believe we need to go through each one of those. As far as you get the first two, you should be all right. So other than the chapter discussion for this week, if you notice my post for my class 310 announcement for this week, what else required? I'm going to post another simple class activity from each from 6.4 and 5. And thereafter, I will post the class discussion session back to class discussion session back to Canvas, so you will be able to access it again if you want to. And other than that, your exam 3 is coming up Monday next week. Not actually not next week, the week after. So Monday next week will be the 13th. Your exam 3 will be scheduled for Monday 20th April. So you may spend your entire day to answer the exam 3 if you want to. You can keep it saved until the end of the day and get it submitted before midnight. So there's no 2 hour or no 3 hour time limit. So you have full day to answer the questions. Uh, uh, then uh, then submit it before the end of the day. Okay, one student is asking a question about, you know, oh, that's the issue. Link is wrong. Let me see.
Both of your links bring it to the other sections.
Is it?
Yep.
Oh,
I had to go back to week 12 to find this link.
oh, maybe I made a mistake there. Let me.
I'm in the same boat.
That's why we are missing people. Okay, let me quickly edit this. Give me a second. I'll quickly edit this. Okay, any friends that you have contact with, if they are looking for it, ask them to do it now. I changed the link. I've changed the link. Let me quickly. Okay, good. Okay. Let me Go back here and share my screen again. Assignments. Okay. So as I said, again, your exam 3 will be similar to your exam 2, which will be a online exam. So you have full day to get it done. The topics that's gonna cover in exam 3 is listed. Sorry, exam 3 is listed right here. Pick a participant. Right here from chapter 5 and 6. So that's why we had to delay it until we finish chapter 6 today. So then you have full week to go through chapter 6 next week before we answer the exam question Monday week after. Okay. So any other question before I start the discussion on chapter 6.4? No? No questions? Everyone is happy?
Pretty good.
Okay, good. To begin with, so in our previous chapters, so we, in our previous chapters and the first part of this chapter, we went through quite a number of addressing modes so far. So we went through quite a number of addressing modes so far. But we did not go through some of the addressing mode, which is more relevant to the indexes that comes with the arrays. Indexes always comes with the array. Most of the time indexes comes with the arrays. So we're gonna discuss that in this session. So therefore, so addressing mode index array index addressing will come with the similar format, but plus with the index where it is stand from the first index or the pointer that kept for that particular array and how far it is from the given index. So example, the first one that we're going to take with a globally declared array, and the second example will be a locally declared array. If you remember our previous discussion, when you declare a variable globally and when you declare a variable locally, how we treat those two different type of variables in a assembly language is different. Can someone tell me what is the difference between a globally declared variable and a locally declared variable? How we treat them differently? Anyone remember?
Can you repeat the question one more time?
So if you declare a variable globally and if you declare a variable locally, what is the difference when you represent that in assembly language? What
On one of
differences?
my class activity answers, I believe I formatted that in a way. I didn't really know what I was doing, but it showed the textbook doing it. And it said something about like a push. I can grab it in a second, actually, but I can't exactly remember. But I know that it had to do with like a.
There's one major difference. Anyone else want to answer that?
Is it dot block and dot equate?
Yes. So what is the difference between a dot block and dot equate?
The block is global variable and equate is local.
Okay. So when you declare a variable as a dot block, it's allocate particular memory location from the top of the program or the top of the main memory. But when you declare a dot equate, it's not permanently allocated. At the runtime, whenever that variable space is required, it will be acquired from the stack addressing area, right? Remember the stack relative addressing when you have that. So you have a stack area prepared in the middle of the memory. In the middle of the memory, if you remember the address, if it is FD F8, I can't remember the exact address. It's in the middle. So from somewhere from the middle, you build a stack based on the amount of memory that you need. So now the global declaration will go with dot block that will permanently allocate that space. So a couple of other things that you need to be remembered in the globally declared variables. So to get the element vi, load I into the index registry. So if you remember the previous allocations, most of the time those values will be gone to the accumulator, right? So most of the memory addressings and most of the addressing, most of the operations that we have performed so far, actions has been performed at the accumulator. I know some of you asked, why don't we send it to the index registry? Because index registry has the similar capacity as the accumulator. At what point we're gonna go access the index registry instead of the accumulator? So now this is the time when you, as the name itself says, index registry, when you're dealing with the index, you send those values to the index registry. Everyone remember our architecture in the chapter 2 or 3, rather 3, chapter 3, where you have a organization of von Neumann architecture of the PEP9 computer. So there you have a index registry and the accumulator, both of the size of 2 bytes, which is 16 bits. So almost all instruction that we have sent so far, except the dummy examples that we discussed with the index registry, everything else being sent to the accumulator. So now here you are sending it to the index registry with X instead of A. And as you do it, so we're going to use this ASLX as a part of this program. So when you deal with the index registry, so you need to switch your location from one to another. You start with the starting location of the array and you need to move forward. Let's say, as you see here, the globally declared variables. So you start your index right here. Then you need to go down to other indexes. You need to go down to other indexes. We use arithmetic shift to the left in order to calculate that. Let me go back now to our example to better explain that. So example is a simple program with a array name vector with the size of 4. So do not get confused over this vector about vector arrays. Have you all, anyone, my 200 class, if anyone who has taken 200 with me, I mentioned about the vector arrays. Can someone tell me the difference between a vector array and a standard array? At least one of you remembered? No? If not, that's okay. So vector arrays are special kind of arrays that you can use in a programming if you believe that the size of the array may get expanded later. If you believe that the size of the array may get expanded later, you use a vector array instead of a standard array. But if you know the size of array is fixed and you're never gonna change, so you can keep it as it is. Let's say if you are opening it up for a online or maybe a public conference or something. So you don't know how many people are gonna participate, but you can assume that, okay, depending on your past experience, maybe 50 people participate. So you keep it for 50 of the size. And if you get more participant, instead of creating a new, completely new program, what you do is you expand the size of 50 by adding certain number of elements at a time. You not add one at a time, you will do like a 5 at a time. So if the 51st person trying to register, so you expand the size by 5. Then when you want to have the 56th person register, you expand the size by again by 5 to 60. Likewise, you keep doing that until you you have the full number of participant registered. Does that make sense? What's the difference between a vector array? So when you define a vector array, you need to define the size and the expansion size. So how many elements you add when you expand. But here, even though this is named as a vector array, this is not a vector array. Just the name is vector. Just the name is referred as vector. So to avoid any confusion, that's why I made the explanation. There are special kind of arrays called vector array, but this is not such. This is just an array named as vector. So size is 4. Size is 4 and integer j, another variable, 2 global variables declared. One is an array, one is a variable. And the main program do include 2 for loops. One start from 0, run up to 4, keep incrementing, and that's going to print the vector j. That's going to print vector j. And another for loop that start from 3 and going down to 0 and decrement, print j and vector j. Okay. So let's see how this been implemented using assembly. So as someone answered right at the beginning, as we have 2 globally declared variables, we need to have a space allocated for that. So our array is a vector array. Sorry, our array named as vector, not a vector array. Array is named as vector and with the size of 4 elements. So in order to hold 4, you need to have 8 bits, right? Everyone following me? At least 1 yes?
Yep.
Okay, good. So then you have another variable. So you have a 2 space allocated for that. Then you jump into the main program. Actually, from the beginning, you jump into the main program. Whenever you need to access the array, you go back there. But I explained that before all. So now main program will start with load word 0i. So j will be initially 0. And the store word x. See, all the time it is referring with the index registry or the x. All the time it is going back to the index registry, which is x, because by default program identified this is dealing with a vector. So program will always load values to the index registry. So 0 with the direct addressing I, 0 is being loaded. Then you're gonna store the word 0 as j, 0 as j. Then you copy word 4 to I, because for loop gonna check, compare the word with 4, because your for loop here, your for loop do the comparison with j with 4. So if the for loop satisfy, that is if j is less than 4, but what you do is branch greater than equal. If you remember our for loop and if else condition requirement, instead of checking for the condition that given in the condition, we check for the opposite condition. Everyone remember that?
Yep.
Okay, good. So that's why even though the condition is less than 4, we check for the branch greater than equal 4. If branch is greater than equal, where are you gonna end up? You're gonna end the for loop, right? You're gonna end the for loop. Else, so end the for loop is right here. End the for loop is right here. Before we go to that part, so else we will just move down. So as you see here, so the next instruction, what this will do, ASLX. One of you need to answer this question. ASLX, arithmetic shift left. What will be the end result of arithmetic shifting to a left?
Is that not division like we discussed earlier, or is that to the right?
So that is arithmetic shift to the right, right? When you shift it to the right, remember in the class we discussed, so you divide it by 2 by shifting it to the right. Now, opposite of division is of course multiplication, right? So basically shifting it to the left, it multiplies. Shifting it to the left, it multiplies. So why it is multiplies? So as you see that this addressing mode, how it's gonna do is it's gonna take the operand specification and x as an index. So let's say for an example now, here, you do a arithmetic shift to the left for x. So when you perform that action, what is the value in the accumulator? Who can tell me what's the value in the accumulator before we shift it to the left?
Well, isn't X for the register Like, isn't the accumulator not being used?
Say it again.
Does the X at the end of each of these commands mean that they're using the register instead of the accumulator?
So, sorry. Yes, yeah, index register. What is the value in the index register? You're right. What is the value in the index registry?
We just have 0 in it because we loaded 0 indirectly. No.
So you store the word J, right? Store the word J. You compare the word with 4. When you do the compare, so you copy the word of 4, you branch greater, sorry, you compare the word, you branch greater than equal, you compare it with 0. In order to compare it with 0, do you load 0 to the registry? Are we loading the 0 to the registry, or you just compare? Because the instruction will deal with 0, right? So what we do is you already have a value loaded to an index registry. So you compare the value in the index registry with 0. Does that make sense to everyone? You don't load the 0 to the index registry. Question? No questions? Does that mean everyone understand that, or any comments? Hello? I'm expecting a response.
So for, you were saying it was 0, it wouldn't be 0 in the register because what?
Because, so with the immediate addressing, you already loaded 4, right? You compare the 4 with the registry. So what? So then you compare, then you branch if it is greater than equal to 0, right?
Right.
So does that mean your registry value is changed as a result of that?
I wouldn't think so. I would think it just stays what it was
Okay.
beginning with
So
before you compare.
that's what it is. So now what is the value in the registry then? Index registry.
It should still be 0.
Okay. So then you shift it to the left.
And it should still be 0.
Okay, you shift it to the left. It will still will be 0. So now you call for the decimal in vector x. Decimal in vector x. So x here is referring to this address mode that we just discussed here. Index addressing, index addressing. So what's gonna happen is, so the value for the vector is taken. Value for the vector is taken. So in your value here, the vector is taken. It's gonna take the address of the vector, which is 0003, right?
Yep.
Okay, 0003. 0003, and it is gonna compare with the value in that particular. Sorry, it is not gonna compare. It's gonna store temporary. You have a value now at the vectors point 0, so you're gonna compare that with vector index 0, and move to the next instruction. Move to the next instruction. So then now you have a this instruction passed. You increment the j with 1. You increment the j with 1. So in order to do that, you add a 1 to the accumulator. You add 1 to the accumulator, store it back to the j. Then you branch for for loop again until you dissatisfy the condition. Until you dissatisfy the condition. As soon as the condition is dissatisfied, that means end of for loop 1. End of for loop 1, then you go to the second part, which is the second for loop. Is that clear, everyone? So I don't believe I need to go through each one of these instructions, because basically it is the same thing, but the opposite direction, because you start with a larger value and go up to 0 instead of going from a smaller value to a larger value. So that's why you have branch less than here. So you have branch less than here because in your for loop, what you have is j greater than or equivalent to 0. So instead of greater than or equivalent to 0, what we do is branch less than. Again, the same condition apply for loop, and you get it terminated when the program terminates, when the loop terminates. So this is the globally declared variables, and your index keep incrementing until you complete the program. And that's how it is. Any question? Because if you get this, the second one is pretty easy.
Does the amount of space you have to allocate for an array change based on how many spaces you allocate for the array, like 8 slots of the array or something like that?
Of course, yes. So let's say the this program, you have a vector size of 4, right?
Yep.
So vector size of 4. So as you have the vector size of 4, we allocated 8 bits. So 8 bytes rather.
So always allocate just 2 times how much you actually have in the
That's right.
array.
So as you see here, because these are 2 decimals, right? 2 bytes for a decimal, and basically you have a 4 array indexes. Array indexes can be allocated with 8 using each size of the 2.
But
Is it
like a vector for like letters would be 4 bytes still, right?
like 4. Say it again. I didn't get that exactly.
If it's a bunch of characters, wouldn't it still be 4 bytes?
Yes. You're right. Yeah, because if it is a integer size of 2, that's why we went with 8. You're right. It's depend on what variable type. So as the decimal as integer need 2 points, that's why we ended up allocating 8. Are we good to move to the next one?
Yep.
Okay. So the locally declared variables, nothing much difference here except where you kept your variable saved, rather array saved. So now in this, as you see it here, now your vector is declared as a local variable, right? Vector as well as this j is declared as a local variable. So as a result of that, instead of going for a declaration, which is a block, you go with the equate declaration. And the vector is defined with a size of 2, and j is defined with size of vector is started at the location 2, index addressing, relative index addressing at 2, and the j is kept at 0, because in this addressing mode, if you remember, so you keep the addressing mode starting, see FB8 D is the lowest point. From there, you need to have a 5 spaces allocated. As you see here, the j is given the topmost stack location, and the rest is stored right here, starting from here to there. So you have 4 indexes from 2 to 8. that's going to store the value vector 0 to vector 3, the 4 vector array locations. So now, when you execute the program, do you remember that when we do the stack relative, so you always started it with a pushing the size of the stack that you need to build before you start the execution. So we need a 10, rather 5 integer spaces. In order to accommodate 5 integer spaces, you need to have a 10 bytes allocated from the stack. So basically doing this will push the entire vector and the j into the stack, allocating 5 spaces. And the rest remain the same: load word 0i, store word js. So now instead of going for anything else, now here the store word is j stack relative. Yes. And the compare word with 4, and branch greater than equal, this not change because the for loop remain the same. If you see it here, see this for loop, 2 for loops are remain the same, nothing has been changed. Compare with 4, branch greater than equivalent, then you end the for loop, then you do the similar arithmetic shifting, decimal in to load the vector. So now the addressing mode is not anything but sx. See, sx stacked index. So previously it is just an index, now stack base index. So your index is starting from where the stack is implemented, relative to this relative to the stack index index. I know at the beginning of the semester when some people ask about the pointers, I also mentioned this. So if you keep a pointer counted for any variable that you declare, now you will see in the memory. So you just need to point it, even though you have a 4 spaces in this vector, you just need to know where the starting address is. By knowing the starting address, you can add the relative value to that starting address and find the remaining stack indexes. Is that clear to everyone? Remember at the beginning of the semester, people ask why we really need a pointer, because pointer itself accommodates some space. So now, this is giving you an answer for that, because you have a 4 variables. If you know where it is start, which is at stack relative point location is 2, so that's what you see here. See, the vector is started at location 2, your stack relative addressing. As far as you know that, by adding the size of a relevant size of the index, multiply with the number of indexes, you can find any index variable within that array. So you repeat the same, you add 1, store word back, and branch to for loop 1, and keep doing that until you break the comparison. Then if the comparison has been broken, you jump into the for loop, you end the for loop 1, then you repeat the same for loop 2. Is that clear? Questions?
Can you go back to the first slide?
This one?
Yeah.
Okay.
What I was trying to explain at the beginning of class between local and global variables, I thought it was that sub stack pointer thing. I didn't know what that meant, and the push vector j, because I saw that in a video example you had last week.
So in a globally declared variable, you basically allocate the space globally. That space is permanently allocated, regardless of the array or any other type of variable. You permanently allocate that variable from your program itself. So as you see it here, so you start the location from 0003, it's run up to 00B. See, from 0003 to 000B. Then your main program start the execution soon after that at 000D, right? Because B and C is being used by the variable J. Then your program start from 000D. So now here in this one, see you start the program again at 0003. So you allocate vector J and vector and J, but your program start right here at 0003. You notice that?
Yeah.
Yes. So why? Because even though you declare it here, this is not a global variable. This space been allocated stack relatively in the location right here, starting from FB8D. So any stack relative variable that you allocate in your program will be referred from this location to the top. So space is being allocated starting from this to the top, because that's why you subtract. When you subtract, that means if you consider the memory as a top to bottom structure, when you subtract, basically you go up, right? So when you subtract, you go up. You subtracted 10, that will bring you up to this level. So that's why when you subtract 10, your initial stack pointer is right here in the bottom. Now your stack pointer is 10 level up because you subtracted 10. Because right below is higher number, above is a lower number. You subtract and you go to the lower number. Is that answer to your question?
Yeah, I was much more so knowledgeable than I was before. Thank you.
Okay. Anyone else have any other questions? Okay, I'm not going to spend more time on the next two examples in 6.4. So it's basically the same array, probably a little detail array as you pass it through as a parameter, in your method. So example is right here in the slide as well as in the video description that I posted. So go through that, and if you have questions, feel free to contact me because I had to go through another part today to make you prepared for your exam 3. So you will be done with chapter 6 after today's discussion. So even last week, I had at least 1 or 2 students who schedule an individual meeting with me to get some of those concepts explained. I am open for that. As many of you are finding it somewhat hard to get connected live during our live sessions, it's okay. Find your own time and contact me. I will find my time to meet you and explain you any question you may have. Okay, let me move into the next part, which is the pointers. Basically, pointers are the one that we discussed in the past, but to better explain that, pointers are dealing with something called malloc. Anyone remember the word malloc in the past? Who remembered word malloc?
Memory allocation.
Yes, memory allocation. So what is the benefit of memory allocation in C programming with compared to the previous program languages? What is the benefit of memory allocation? Anyone? So when you declare a variable in your Java programming, so you declare a variable. At one time you use it, sometimes you do not. So Java do have something called garbage collector. If there's any unused variable, so by default it will be sent to a garbage to free up your memory. So C do have something even beyond that. So only when you need to use a certain memory, you allocate it with a system call a memory allocation, which is referred as a malloc. So only when you call the variable with malloc, it's allocate that memory. And if you want to free it up, you can just call it with the command called free. That will free the memory allocation. So even within a program in a given method, sometimes you can allocate the memory, sometimes you can deallocate the memory. So most of the time in your C programming, so your variable or your memory space will be kept unused unless otherwise it is in use. Does that make sense if I say so? So Java do have similar options, but not detailed as memory allocations in C. So C only allocate a memory only if and only if it is in use. So to better understand, the example that given here in the textbook is a 3 integer pointer variables created here, integer A, B, C, integer A, B, and C. So those are declared globally again. So again, if I throw you back the same question, if you declare a variable globally, how are we going to deal with this? With block, right? Is this slide is this web page is readable, or is it too small?
It's readable.
Readable, okay. So let me try making it a little larger. Okay. So now you have your A, B, and C, 3 variables declared globally. Then you have your main method, and inside your main method, you assign the value A with integer malloc, the size of the integer, and then you allocate value 5, the memory address, the variable address A. Then you repeat the same with B. Then you reallocate the value of A to C. Then you do another allocation for the value of B to A. And finally you do location A is equal to 2 plus C, 2 plus C. So how are we going to do this? So now at the beginning, you have to have 3 variables created as a global variable. So each with the size of 2, because why? Why each one of those size of 2? Anyone? Because those are integer, right? And can someone tell me why this is kept as 2H? Why this is 2H, not 2D? Anyone? These 3 global variables are declared as 2H but not 2D. If you remember our previous examples here, almost everything, see, these are 2D local variables. Even the global variables that we declared are 2D.
Is it because they're pointers?
Exactly, because they are pointers. Because of their pointers, we need to keep because of their pointers, we need to keep the hexadecimal value, the address, right? H stands for the hexadecimal. So basically what it is, the hold is an address. So don't worry about the swapping at first place. So we will come back to the swapping. So what we're going to experience here is, see, so you have A, B, and C. 3 are pointer variables that point to some other variables, right? Point to some other variables. So basically A, B, and C are 0303, 005, and 007, and those will hold location 0081, 0081, and 007F. So if you asking why it is 0081, so that will be answered as we execute the program. But keep in mind, these 3 variables are holding addresses of 2 other variables, 5 and 7. So how this become 5 and 7 is part of the program. Let's see how it become 5 and 7 now. So you have 3 blocks created. Then you start the program, load word 2i, Why it is 2i? Anyone? Why it is 2i?
Because integers take up two.
Exactly. Integers take 2 in the immediate addressing. Then you call for the malloc. Remember we used call previously. Where else we use call? We use the call variable previously, right? So call with the malloc. So allocate 2d for the malloc. So now, what is this malloc? So if you notice it here, this is a label. It is not declared here. What is malloc is not declared here. At the bottom of the program, how the mallocs work. So you call for the malloc here. At the bottom of the program right here, how the mallocs work being explained. So we will come to that later. Before we know how the mallocs work in the assembly, we will see how is that program works in the correct order or not. So let's see, you start with the load word 2i, you call for the malloc. So malloc will allocate the memory. So that's what our expectation. So then the store word to x again to the index registry. A with direct addressing. So what is A here now? What is A here? Anyone?
Would it just be, oh, it'd be what was in the accumulator. So is it not 2, or does the malloc change that?
So load word to the accumulator 2, because that is 2, as someone answered a little while ago, because that's the size of any integer. When you call for the malloc, so you store word to index registry A with direct addressing. What is A here? If I pull it out from here. So what would be A here? Anyone?
7.
A is 7. So that is after the execution. That is after the execution, A is 7. That is right. So that is because A gonna become 2 plus C, because C is 5, 2 plus C become 5, which is 7. But before that, A is not 7. So store word X with A with the direct addressing. So it's gonna store the address of the A, right? Address of the A. So now the load word 5 with immediate addressing. Why we load the word 5 with immediate addressing? Because 5 is what we need to assign to the pointer A, right? 5 is the number that you need to assign to pointer A. So initially A will have an address. Then you take the 5 with the immediate addressing, and now thereafter star A become 5. Does that make sense? Anyone? Does that make sense? At least one person I wanna see an answer. So you load with the immediate addressing 5. So now asterisk A become 5 when you store the word to the accumulator. Is that clear?
I wouldn't say entirely, but I feel somewhat confident, yes.
Okay. So now, so first you load the address of the A, then you take the value 5 and assign it to A. So this is actually the completed answer. So at the beginning, you keep A pointed to 5. So at the beginning, you keep the A pointed to 5. See this arrow is going to 7 because that's at the end of the execution, but before it should be just 5. So now, then you load again the same thing is being executed to this line. So you load again, integer size is 2. You load 3 to the B. You load 3 to the B. You load 3 to the B with the immediate addressing. So after that, you store the word back to 3, and B become, where's that? Okay. B become 3. Is that right?
Yeah.
Okay. Yes.
I'm understanding now what you were explaining before, but why is it again that you can't do dot equate?
Why can't it be dot equate? Because this is declared globally. So it's about how the assembly deal with variable that is being declared in the program itself, because this value can be used anywhere in the program, right?
Yeah.
ABC values can be used anywhere in the program. Assume you have one another method. So still you should be able to use it A, B, and C. Even if it is modified within the program, those modifications should not have been altered until your program execution is being completed. If you declare it as a dot equate, what happened will be, it is relevant, it is locally declared just for that given function or a method. As soon as that function, that local domain is being expired, those values are no longer exist. Does that make sense?
Yep.
Okay, so as we are running out of time, let me quickly complete this example. So you take the value, then you store it to the B. Then what you do is you take the A value, add 2, and store it to, sorry, you take the value of C and add 2 and store it to A. Before that, if you notice it here in the program, so before that you change A to C. Now C also become 5, right? When you assign A to C, C also become 5. So both A and C become 5. After both A and C become 5, what we do is you change A to B. Now A will have value of B. A will have value of B would be what? The 3, am I right?
I lost track at this point, but I think
Yeah,
so.
even I lost the track. Let's see. A was 5. Then B was 3, is that right? Yeah, B was 3. So C become A. So that means C is 5 now. C is 5. Then A become B. B is 3, right? B is 3. Basically here, the location B is pointed to 3. So by doing B equivalent 3, basically A also pointed to B. So then the A become 2 plus C, because C is 5 and C plus 2 is 5 plus 2 is 7, right? Right? 2 plus C is 5 plus 2, which is 7.
Yep.
So now A become 7, and the same time the B also becomes 7, because now A and B are both kind of equivalent. So even though we have not changed B, B also changed to 7 because we changed A, because A and B are both pointed to 7. Does that make sense how that change happened?
Yeah.
Okay. So now finally, to give you like a quick overview how the malloc works. So in the malloc, you load the word to accumulator, you add any given value that is, sorry, load the word to the index registry, you add the value from the accumulator and store the word back to the accumulator. So the malloc, what you do is you take a temporary memory from the index registry and perform a allocation. So we call it a heap. So in a malloc allocation, what we do is we always maintain a heap in our structure. People who have taken 200 know what heap is. Even the people who are not taken 200, I briefly explained. Heap do have a kind of a top to bottom structure. So you may have one on the top, then you have a more nodes attached to the top instruction. So heap will take the topmost element out and add and store the word back, then the return. So basically malloc will perform all of these. So heap pointer will be directly addressing and return the address of the heap. So again, another set of memory location that you maintain under this to keep track of these variables. So let's say for an example here, so these values are not the part of the heap, but heap will deal with these, malloc will deal with these values as a part of heap. So heap doesn't have its own memory allocation. Heap keep track of these addresses as a part of its structure. Yeah, it took a little bit of extra time than I expected. What I could do is I will, again, I'll keep myself available this Friday. Anyone who has a question, feel free to join in lively if you need any explanation. And I will post a, your homework assignment 5, I kept the deadline until tonight. If you have not completed, get it done before midnight. And I've already posted your next homework assignment. I know we are not covered everything that you need to complete the homework assignment, but you may spend time on it. And I will post a quick activity based on this chapter for you to get yourself prepared for your exam 3. Okay. We ran out of time, so feel free to sign off if you have any other classes coming up. If you have questions, you can stay and ask any question that you may have. No questions?
I'm all good. Thank you, Professor Chana.
All right, Ian, take care.
Chana.
Yeah.
In that last one, what was the point of switching between A equals versus asterisk A equals and stuff
Okay,
like
give me a
that?
second. Let me
What was
post the screen, not the share, but I'm gonna post the recording. Let's see.